Hi guys, today we're going to talk about graphing quadratic inequalities. So at this point you should have already graphed quadratic equations. You should know how to find the axis of symmetry, the y-intercept, the vertex. And so all we're going to do today is make sure that we use the same knowledge of graphing linear inequalities, where if the symbol has the equal to underneath it, then you draw a solid line, and in this case a solid curve. And if it does not have the equal to symbol up underneath, then you'll just draw a dashed, or you'll make it dotted. And then don't forget your shading. Anytime you have inequalities, you have to make sure the line is correct, whether it's solid or dashed, and make sure that you shade. So let's just jump right into number one. We're going to graph this inequality, and I strongly urge that you get a separate sheet of paper so that you don't make it really messy. Let's just keep the important information on here. So on my separate sheet of paper, I am going to write down f of x is greater than x squared plus 2x minus 2. Okay, now I want to go ahead and find the axis of symmetry and the vertex so that I can fill in my table. So the axis of symmetry, we start with x equals the opposite of b, so the negative 2 over 2 times a, which is 1. So negative 2 over 2, that's negative 1. So at negative 1, I know I have an axis of symmetry. I can erase this in just a minute, but for right now I just want to show that there's my axis of symmetry at negative 1. Now recall that if you plug in negative 1 for your x values, then you will get the y value. So if I say negative 1 squared plus 2 times negative 1 minus 2, so I'll have 1 minus 2 minus 2. 1 minus 2 is minus 1. Minus 2. I have negative 3. So my vertex is negative 1 comma negative 3. So I know negative 1 comma negative 3 is right here. Now I'm going to put this in the center of this table. Negative 1, negative 3, that's the point there. And I want to try to figure out other values around. Well, I know when x is 0, that would be I would land on the y-axis somewhere, which is the y-intercept. And remember that the c value is your y-intercept. So negative 2. So at 0, I'm down to negative 2. Let's see what happens at 1. If I plug in 1, I'm just going to go over here to the side. I'll have 1 squared plus 2 times 1 minus 2. 1 plus 2 minus 2. 1 plus 2 is 3. And 3 minus 2 is 1. So if I plug in 1 and I get 1 out, 1, 1 would be the point. So at 1 I have 1. At 1 I have 1. Now remember that all of these points will reflect over the axis of symmetry except the vertex, because that is the turning point. So this should reflect across the axis of symmetry, and we can double check by plugging in negative 1, negative 2 for x, negative 2 for x, and making sure that we get negative 2 for y. So again, plug in negative 2 for your x values. Negative 2 squared plus 2 times negative 2 minus 2. 4 minus 4 minus 2. 0 minus 2 is negative 2. So I plugged in negative 2 and I got out negative 2. So negative 2, negative 2, which is this point. Okay, at negative 3, I should have a reflection here. So I should have 1 at negative 3. Let's double check that. If I plug in negative 3 and square it, plus 2 times negative 3 minus 2. 9 minus 6 minus 2. 3 minus 2 is 1. So at negative 3, when I plugged it in, I got 1. Negative 3, 1. Okay, and of course we can continue. Negative 4, let's see what happens at negative 4. Negative 4, square it, plus 2 times negative 4 minus 2. 16 minus 8 minus 2. 16 minus 8 is 8, minus 2 is 6. So at negative 4, I get 6. Negative 4, I get 6. Negative 4 is here. And I go up 6. 1, 2, 3, 4, 5, 6, which means I should have a reflection across the axis of symmetry. 1, 2, 3 is the axis of symmetry. 1, 2, 3. So I should be at x equals 1, 2. Okay, so at 2, I should have 6. And of course, you can plug that in and check it. Let's go ahead and graph this correctly. Looking at the symbol, it says it's greater than. It does not have the equal to line up underneath the symbol, so we're going to draw it dashed. Okay, dash it, dash, 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 dash. You still want to put the arrows on the ends because this does continue to go on forever and ever. And then read number 3, how to shade. You shade above the line for greater than or greater than equal to. So above it. If you think about if you were to pull this parabola down, if you were to stretch it down to where it was a straight line and it was horizontal, and then you shade it above it. So if I tore this down and made it straight, I would shade on top, and then if I put it back together, all that shading would go right in here. So this is where you shade for this parabola. Okay, let's try the next one. F of x is less than or equal to negative x squared plus 4x minus 1. I'm going to write that down. Okay, and let's start by finding the vertex. So I need the axis of symmetry first. X equals the opposite of b, negative 4, over 2 times a. Be careful, your a is negative here. So negative 4 over negative 2 is just positive 2. So x equals 2. That's where my axis of symmetry is. X equals 2. Okay, plug it back in to get the vertex. All right, so we've got a negative, and then I have my x squared plus 4 times the x minus 1. So I have 2 squared is 4, but I have that negative on the outside, plus 8 minus 1. So I have 4 minus 1, which is 3. So when I plugged in the value of 2, I got 3. That is my vertex. When I plugged in 2, I got 3. And if you recall, since the a value is negative, my parabola should open downward. All right, let's put our vertex in the center here, 2 and 3. Okay, now we plug in points around there or find your y-intercept. So I know that the y-intercept is when x is 0, when the x value is 0. So I'm going to go 0 here. So I'm going to go down, decrease my values here, and I'll increase my values here. Okay, so at 0, when x is 0, that is the y-intercept, which is the c value, so negative 1. So at 0, I'm at negative 1. Okay. Well, let's see what happens at 1, which, by the way, I can go ahead and go across my axis of symmetry from this point. So right here, and I can identify that point as this is 1, 2, 3, 4. So at 4, negative 1. And notice it is symmetrical in how it's lined up in the table too. Okay? All right, so let's look at what happens at 1. At 1, I'm going to plug in, I have negative, the x value is 1, I have to square it, plus 4 times the x value of 1 minus 1. And I have 1 squared is 1, so I end up with negative 1 plus 4 minus 1. This is 3 minus 1, oops, thinking ahead, which is 2. So when I plugged in 1, I got 2. When I plugged in 1, I got 2. At 1, I get 2. Which also means that if I reflect it across the axis of symmetry, I go right here, which is 3, 2. So at 3 I have 2, and again, it's symmetrically lining up here. All right, now I do want to show you one more, only because a lot of students have trouble when this negative is in front here, and then they have to plug in a negative value for x. So I wanna just make sure that everybody's okay with that. If I plug in a negative for this x value, that does not do anything to this negative. This negative is part of the equation. The negative that I'm going to plug in is part of my x. So I keep the negative part of the equation, and then I say, okay, my x value is negative 1. And then I have to square that. Plus 4 times negative 1. The problem doesn't exist usually in the center of the problem or anywhere else. It's usually at the beginning. If you see a negative, just be really careful and make sure you plug in correctly for whatever x is. I still have to do my exponents first. So this is going to be 1, which will turn this into negative 1. This will turn it into negative 1. Minus 4 minus 1. Okay, so this will be negative 5 minus 1, which is negative 6. So when I plugged in negative 1, I got negative 6. So my point is at negative 1, negative 6, which also means the 5 should be at negative 6. But let's see. At negative 1, I go down negative 6. 1, 2, 3, 4, 5, 6. Yep. And then I look at this, and this is 4 spaces, or 1, 2, 3, 1, 2, 3. So I'm making sure it's symmetrical, and make sure this is at 5. 1, 2, 3, 4, 5. That is correct. So this was also at negative 6. All right, so now we have all of our points, and let's graph the line appropriately, or the curve appropriately. We have an equal to up underneath, so we need to make sure it's solid. So we draw solid line, arrows, don't forget your arrows. Okay, and at this point we go less than or equal to. Now it says shade above the line for greater than or greater than equal to, and below the line for less than or less than equal to. Again, if you are having trouble figuring out which part is above or below, imagine just taking and grabbing the parabola, straightening it out. Where would it go if it were below? Down here. And then if you push the parabola back together, all of that shading would go inside here. Now, these two problems both had shading inside of the parabola, but that doesn't mean it's always going to be inside. If my parabola opened upward, and I had to shade below it, then I would have shaded all on the outside in the boxy area here. Okay, so don't think that it always has to be shaded on the inside. Those are the two examples that I'm going to do. I want you to complete the rest of this worksheet, and let me know if you have any questions. All right, we'll see you soon.